Welcome all of you to this video of Maths Made Easy. Now in this video, this is a continuation of the chapter Matrix I have uploaded part 1 before this. This is the second part of matrices. Here we are going to take little more difficult topics, and in this topic I am going to take up two types of multiplication of matrices. Okay, one is scalar multiplication and one is multiplication of matrix with another matrix. So both are quite different things. See the video till the end. I am going to take up some very difficult type of questions where you tend to go wrong in this chapter, though the chapter seems to be easy. If you have not subscribed the channel till now, you can subscribe it because I shall be uploading after this one video where I shall be uploading questions, all past years SSC questions on this topic. Okay, so I shall be doing it individually for every chapter. For every chapter, past SSC questions I shall be taking up in separate videos. Okay, also many worksheets will also be uploaded. Another thing I want to tell all of you is that subscription, this is not a paid channel, so you don't have to pay anything for a subscription. Okay, you just have to press the subscribe button and you keep getting notifications whenever I upload a video. Okay then, so let us start. Now what I mean by scalar multiplication. Yes. What is scalar multiplication? Now scalar multiplication is, now there are two types of matrix multiplications as I said. So scalar multiplication is, let's take 3, it's very simple, 5 and minus 2. Then if I want to multiply this 5 with this matrix, I just have to make it 15 and multiply it here also. So multiply with this element and this element, that makes it this. So multiply with each and every element, that is a scalar multiplication. Supposing I want to multiply here, so minus 1, 0, okay, 2 and 1. Okay, so here also scalar multiplication is a minus 7, 14, 7 into 0, 0 and a 7. Over. So this is what scalar multiplication means. Okay, so with each and every element you just multiply that value. That is a scalar multiplication. So let me take up few sums so you get a better idea of this. Supposing A is equal to, you have to find 2A plus 3A dash. How do you find 2A plus 3A dash? Now if this is A, you have to find 2A plus 3A dash. So what is 2A? Let me first, now here be very specific, find each and every part separately. Okay, 2A is minus 6, then 12 and then 0 because I am multiplying this with a 2 and a minus 18. But then 3A dash. Now you have to be a little careful about 3A dash where you will be first writing A dash. Okay, I have written the 3. And now the A dash. A dash is minus 3, 6 and a 0 and a minus 9. Rows become columns and columns become rows. So minus 9 and a 0 and an 18 and a minus 27. So this is my 3A dash matrix. Now they have told add them. So even without writing them together, you can just add. Addition, you don't have to write them together. Minus 6, not this, minus 6. Minus 9, minus 15, 12 and a 0, this is 12, okay, 0 and 18, this is 18 and minus 18, minus 27, that makes it a minus 18 and minus 27 makes it a minus 45, okay. So this is where I have 2A plus 3A dash matrix ready, okay. Now what if they ask us this? This can be a doubt, minus 3 A dash. Now note this. How to do this? Okay, where they have a fraction here. So let me get half A first. Okay, minus 3 by 2 and this divided by 2, 3. Divide it all at once. 0 by anything is a 0. And here divided by 2 is minus 9 by 2. Okay, so I have got this part. And then 1/3 A dash. So first I'll write 1/3, then I'll write A dash first. Here I need to write the A dash because I don't have it in front of me. Minus 3, 6, 0 and minus 9. And then I start dividing. This is a minus 1, this is a 0. This is a, you multiply with a 1/3, means you are dividing with a 3. Okay, so that is 2 and then minus 3. So I have got both of them. Now I just need to subtract. So half a minus 1/3 a dash is going to be, from this subtract this. That means from this subtract that. So if I write like that, minus 3/2 plus 1, I am subtracting, so minus 1, that makes a plus 1. 3 minus 0, that is a 3. Okay, this is 0 minus 2, that's a minus 2, and minus 9/2 and then plus 3 minus 3, that makes it a plus 3. So here it is minus 1/2 plus 1, that makes a minus half, then 3, then minus 2, and this is minus 4/2 plus 3, that is minus 1/2. Okay, you can write 3/2 also, because this is 4/2, minus 4/2 plus 3. So it is minus 3/2. Okay, so this is it. So I have got my answer ready. Okay, so this was one question where we had little bit of fractions, and sometimes when you are new at it, you feel that how should I handle the fractions? It is nothing but a pure multiplication with that fraction. Okay, now this is how the question is asked. Okay, minus 2y, that is equal to 3 minus 1, 0, 4 and 1. So this is my sum. They are saying if I is a unit matrix, I is always referred to as a unit matrix also only, and of order 2/2, because I can be of different orders. Okay, it can be 3/3. So it is only 2/2. Find M such that this is followed. Okay, so we have to find the matrix M with this condition. Now what we do here is M minus 2, and let's write I. See, unit matrix 2/2 I have written. Okay, now I'll multiply this and get this also ready this side. So we'll try to do the sums in minimum number of steps and this. So this is M is equal to, okay, how much? Minus 3, 0, 12 and 3, and here this is plus 2, I am multiplying now, okay, and 0 and 0 and 2. Okay, so now M is how much? Now I shall be adding it. So it goes just like linear equation only. Here minus 1 and 0 plus 0 is a 0. 12, yes, that's a 12 and 5. Okay, so this is the final matrix, the matrix M. We have found the matrix M now. Okay, so what we have to do, these are scalar multiplications. I can see this is also a scalar multiplication. Get this part ready, take it to the other side, minus to plus it becomes, use addition of matrices, get the answer. Now here I have multiplication of matrices. Okay, now multiplication of matrices is very different from scalar multiplication which we just did, and there is something called compatibility of multiplication of matrices. What is that compatibility? That is, if I am multiplying matrix A with matrix B, then this becomes the left hand side, this becomes the right hand side matrix. Okay, then it can, they are compatible for multiplication if and only if number of columns in A is equal to number of rows in B. Okay, then only you can multiply. So meaning of compatibility is, this is compatibility. So compatibility of two matrices for multiplication is number of columns in the first matrix, the left hand side, has to be equal to number of rows in the second one. Now let me show one. Matrix A, if matrix A is a 3, 4, 5 and 0, let's say, and matrix B is a 1, 2, 3 and 4. Now I want to multiply. Okay, so A, B, first thing, till now I never told that you should write the matrices in the proper place, but here I will always tell, whenever there is matrix multiplication, do write them in the proper place. You don't need it this much for addition or subtraction, but for multiplication, writing in this format is a must. If you are trying to multiply from here or from the question paper, you have a very high chances of not getting the sum. Okay, now here I shall be taking this okay, this one, and multiplying with this. Look here, this way, this way. That is my first step. Okay, and see where I write it. So here 3 with the 1. Okay, let me write it only. 3 with 1 plus 4 into 3. That's my first element. This is not two elements. Then 3 with the 2. 3 into 2 plus 4 into 4. Okay, then comes this 5 into 1 plus 0 into 3. Okay, that means I have gone this way and this way. This way rows, that way column. This order has to be followed strictly. If you can't do it the other way around. And then it is 5 into 2. 5 into 2 and plus 0 into 4. Now what happens? Now what happens here is, see, here you should not be adding the 1 and 4 first simply because you feel like it. Here remember they are following BODMAS. So strictly this has to be followed. Means multiplication first and then addition. So here 3 into 1, 3 plus 12, that's a 15. This is 16 plus 6, that is a 22. Okay, 16 plus 6, 22. Then 5, this is 0, 10, this is, okay. So AB is, how much is AB? 15, 22, 5 and 10. I repeat, this one this way, first multiplication goes here. This one with the second column, first row, second column goes here. Okay, this is first row, first column comes here, and first row, second column comes here, and then follow BODMAS and add and write out. So this is matrix multiplication. Remember, matrix AB is very different from matrix BA. If you are supposed to give matrix BA, you have to write B first and A later and then do the multiplication. Okay, now here is a question. Solve for x and y. Solve for x and y. Now very often this type of questions are asked. So here it is x plus y, x minus 4. So this is a row matrix. Okay, and here it is minus 1, minus 2, 2 and 2. And they are saying that is equal to minus 7, minus 11. Okay, so with this much they are telling find the values of x and y. Solve for x and y means find the values of x and y. Okay, so how do we find it? Now here, okay, now how do we find it? Here, first thing, when we start matrix multiplication and we see that there is some mismatch in the order, we should first go for the checking the compatibility. Can we at all multiply them? Can we at all multiply these two? Okay, so here number of rows is 1 and number of columns is there 2. But then what is the test of compatibility? Compatibility test says number of columns in A is equal to number of rows in B. Number of columns in A, okay, number of columns in A, which is 2, is equal to number of rows in B, then fine, we can go ahead and multiply. Okay, that means this is, what is the order here? This is 1 into 2. Okay, when we write the order, we first write the rows, then the columns, and this is 2 by 2. So number of columns has to be, this one has to be equal to this, only then we can multiply. So sure, we can multiply in this sum. Okay, so now we shall start multiplying. So here this one goes with this. So here it is minus 1. With minus 1 I am multiplying this part. Minus x minus y. Okay, and then this comes. Okay, this will get multiplied with this plus 2x minus 8. That is my first column. Okay, that is my first column, and so I start the matrix here. Now this with this, and it gets written here. Okay, so this is minus 2x minus 2y okay, and multiplied with both, and this one gets multiplied with this. So this gets multiplied with this much gets multiplied with this first element, the second element gets multiplied with the 2 here. So plus 2x minus 8 closed, okay. So here I get a row matrix only, and this, okay. So here I get a row matrix only, okay, minus 7 and minus 11. Now here I just copy this down here. Now what I'm going to do here is I'm going to simplify it here itself, because before I start calculating. So here it is 2x minus x minus y minus 8, it has become shorter also. This goes, so this is minus 2y minus 8, okay, and that is equal to minus 7 and minus 11. Now what do I have? X minus y minus 8 is minus 7. X minus y is a minus 7 plus 8, which is equal to 1. Okay, so x minus y is a 1. Let me go for the second equation. So from this first element, it will get equated to this. I get one equation in x and y. But then if one equation is having x and y both, I can't find the values. One equation should have only one unknown, then I can find the values. So here this one, minus 2y minus 8 is equal to minus 11. Minus 2y is equal to minus 11 plus 8, which is minus 3. Okay, so that is minus 3. So how much is y equal to? Then y becomes equal to, here this is plus 3 by 2. Y becomes equal to plus 3 by 2. Now that plus 3 by 2 I am going to substitute here. So you all know to do simultaneous linear equation. So that is equal to 1. Okay. Then now if that is equal to 1, then x is equal to 1 plus 3 by 2. How much does that come to? Okay, x is equal to 1 plus 3 by 2. That comes to 1.5 plus 1. That comes to 2.5. Okay. Okay, so that is it. So this first thing is to check compatibility, then proceed with your sum. Then it is matrix multiplication, then it is linear equation. Now I have a sum here which is m into, very important, 3, 6, minus 2, 8, minus 8, and that is equal to minus 2 and 16. Now here in this sum, this is, you have to find the matrix M. Now this is no longer plus or minus that I can take it to the other side and multiply and all that. Now this is a product. I can clearly see it's a product. Now how to do it? First thing, I look at this. Okay, what is the order? Order is 1 into 2. First row, then column. This is 2 into 2. And this is A into B. Let us assume it as A into B. Very important sum. Now here, see, since multiplication is possible, then definitely, since they have given this sum, means multiplication is possible, okay. Then here the row number of columns of this is equal to the number of rows of this, right, according to the compatibility rule. So B has to be equal to how much? This is 2, okay. B has to be equal to 2. Now come to the other part of it. Another rule says that if the product matrix has a row as 1, whatever is the number of rows of this, the first matrix to the left will have that many number of rows. So A is equal to 1. Very important. This is a very commonly asked question. Okay, so how much is the, now how do I set up the matrix? This is a 1 by 2 matrix. Now once I have decided on the order, of this matrix, then I shall be first, I'll be writing it. Now this is, see, I am writing xy, means columns is 2 and rows is 1, and then here 3, 6, minus 2, minus 8, okay, and that is equal to minus 2, 16 written. Okay, now I shall start my multiplication. 3x minus 2y, and then it goes 6x minus 8y, and that is equal to minus 2 and the 16. 3x minus 2y is a minus 2. 6x minus 8y is a 16. Okay. So now with these two equations, okay, these two equations, 8y, these two equations I am going to solve by using simultaneous method. Now how do I solve it? You can very easily solve it. Multiply this with a 4 if you want to do that, or you can do that, multiply this equation with a 4. Okay, so how much do I get? This is 12x minus 8y is equal to minus 8, and then I'll just write this equation over here. 6x minus 8y is equal to 16. I shall be subtracting, so this is 6x, this is gone, and that is equal to minus 24. Okay, so that is equal to minus 24, x is equal to minus 4. Okay, and how much is y then? Just substitute in one of the simplest of the equations. So 3 into minus 4 minus 2y is equal to minus 2. So this is minus 2y is minus 2 plus 12, which is 10. 2y minus 2y is 10. Okay, minus 2y is 10. Therefore, y is equal to minus 5. Okay, so now what is my matrix M? I have to give them the final answer. So my matrix M, okay, is equal to, I have to write it like this. Get your answer very clear. Matrix M is, see this format, and then write minus 4, no comma, and minus 5. That's your final answer. Now these sums generally are little long. Okay, be prepared for it. Now they have told us if M is this, show that this, where I is a 2 by 2 unit matrix. So we will just first try out the left hand side. How much is 6m? First thing. Okay, 6m is a 24 and then 6, and I'm just multiplying minus 6 and a 12. 6m ready. Okay, now m square. M square is 4, 1, minus 1, 2. And 4, 1, minus 1, 2. Now we are starting to do m square, but listen here. Now whenever people see a m square, they tend to write it as a 16, 1, 1 and 4. They just square the individual, they just square the individual values, individual elements and do it. Okay, now that is a very wrong method. M square means you have to write it like this and you have to multiply. That's a wrong thing if you do, and you get your sum wrong. So this is 16 minus 1, which is a 15, and then it is 4 plus 2, which is a 6, and then you have minus 4 minus 2, which is a minus 6, and you have minus 1 and 4, which is a 3. So I have m square as this. Okay, this is my value of m square. Now I am going to get this part, fully this part, 6m minus, so 6m minus m square. Okay, so if I can manage it without writing, I'll do that. 24 minus 15 is a 9, and 6 minus 6, that's a 0, minus 6 minus 6, that's a 0 again, and 12 minus, that is a 12 minus 3, that's a 9. Okay, I think I am correct. Now what? Now what is 9, 9? Now this much was my LHS, the left hand side. Let me see the RHS. RHS is equal to 9, 9, which is 9 into 1, 0, 0, 1. That is a 2 by 2 unit matrix. Okay, and that is 9, 0, 0, 9. Okay, therefore yes, we have showed it. So LHS is equal to RHS. Done. Okay. So from this type of sum, what we should be careful of, now every sum you have to be careful about something. So here what we have to be careful about is we should never do m square as 16, 1, 1 and 4. That's the wrong method. M square is supposed to be done like this with proper writing it 2 times. Don't even try it without writing. Now here is a sum which is made up of completely trigonometric values. So here 2 into cos 60 is a half, right? Minus 2 sin 30 is a half again. Here tan 45 is a 1, so minus 1, and this is a 1. Now this is cot 45 is a 1, cosec 30, sin 30 is a half, so cosec 30 is a 2, cos 60 is a half, so sec 60 is a 2, and this is a 1. So let me first get this ready for multiplication. So 1 minus 1 minus 1 and a 1. And here 1, 2, 2 and 1. So we'll start with our sum now. This one with this 1 minus 2, that's a minus 1. Okay, and then 2 minus 1, that's a 1. And this is a minus 1, 2, this is a 1. And this is a minus 2 That's a minus 2 plus 1. Okay, that's a minus 1. So this is our sum. So simple trigonometric values, you have to be very careful when you substitute these values. This sec and cosec can go wrong anytime. Then cot, look at this. Okay, these are all reciprocals of the basic 3 trigonometrical ratios. So be little careful as you substitute the values. So this is how this is a very commonly asked question. Comes every exam, every pre-board, every board is going to come. Okay, so this is how you manage trigonometric values. Nothing, you just substitute the values, and if you have a 2 here, multiply the trigonometric ratio, the value with it. Okay, like I did here. Okay, so that is it from this chapter of matrices. I have tried to take up every possible sum, every possible type of sum, every possible place where you can go wrong in this chapter, in these sums. If you watch the 2 videos and listen to it carefully from the beginning to the end, you are going to get all those sums which can be asked, the types, and every important thing has been done with the help of examples. Okay, so if you have liked the video, do not forget to like, share and subscribe. You'll find all the links in the description box of part 1 and part 2. This is part 2 of matrices. Okay, and you will also get another video during your exams which is going to take up all the important, before your exams you will get all the important past ICSE questions. Okay, past years ICSE questions will be solved in one video. That is only for matrices, one video. You'll get only from linear inequations, one video. Like that, topic wise you'll get videos of past years ICSE questions. Okay, so that's it for today. Thanks then. Bye then.